At week 0, the savings are $40.
Welcome to Function Marsh, where tables, graphs, equations, and narrative descriptions are different waterways charting the exact same relationships. Watch the scene first. A heron wades steadily through the reeds. Here, the quantities are visible in the natural world before they are formally named. By tracking what changes and what stays fixed in the marsh, we find the evidence needed to read mathematical features in context. As we move through these settings, the formal notation will provide a way to record the physical behaviors we observe. This graph represents our first waterway. The horizontal axis tracks the number of elapsed weeks, while the vertical axis tracks total savings. We define the y-intercept as the specific output value when the input is exactly 0. Mapping these axes to our scenario, we see the point 0, 40. This means the account started with $40 at week 0. Locating the y-intercept defines the baseline or starting value for the entire recorded scenario. This data table tracks the height of a projectile as it rises and falls over set intervals of time. To analyze the path, we scan the height column for the greatest numerical value. Here, the highest value shown is 24.
24 units is the greatest height listed in this table.
This peak value is the mathematical maximum of the projectile's path. Based on this data, the maximum height is 24 units. Finding a maximum in a table requires tracking discrete changes in the numbers rather than looking for a visual curve. Consider the description found here. A car starts 120 miles from home and drives toward home at a constant rate. On this coordinate plane, time is mapped against distance. Since the car starts at 120 miles, we place our starting point on the vertical axis at y equals 120. Driving toward home means the distance decreases over time, and a constant rate means the graph must be a straight, downward-sloping line. These descriptive details define the requirements for the graph's structure, specifically where it starts and which direction it moves. We can record mathematical relationships accurately by matching physical evidence to exact numbers and symbols. From the waterways of the marsh, we've identified y-intercepts like the starting $40, maximums like the 24-unit height, and the slope's direction. The environment reveals the relationship, and the notation provides the formal record of what we've seen. Look at the marks in this environment. Which specific mark proves the mathematical relationship, and how does the physical action make it true?
The distance starts at 120 miles and decreases at a constant rate.